Cosmic clashes, a black hole mystery. Black holes collide. These events are powerful. When two black holes merge, they create one of the most energetic events in the universe. The collision is so intense that it can outshine entire galaxies for a brief moment. They release ripples in space-time. We call these ripples gravitational waves. These waves travel across the cosmos, carrying with them the signature of the cataclysmic event that created them. Detecting these waves allows scientists to study the very fabric of the universe. How do these collisions happen? It's a cosmic mystery we are just beginning to unravel. Scientists use advanced telescopes and detectors to observe these phenomena, piecing together clues from the data they collect. One key ingredient in this cosmic recipe is gravity. Not just the intense gravity of the black holes themselves, but the influence of a much larger player, the galaxy they inhabit. The gravitational forces within a galaxy can bring black holes together, setting the stage for their eventual collision. Galaxies are vast islands of stars, gas and dust, all held together by gravity's invisible hand. Each galaxy is a complex ecosystem where gravity shapes the movement and interaction of its components. This same force plays a crucial role in setting the stage for black hole collisions. Understanding these forces helps scientists predict where and when these cosmic events might occur, offering a glimpse into the dynamic and ever-changing universe. From starbirth to black hole, death. To understand black hole collisions, we must first understand how black holes form. They are born from the death throes of massive stars. Stars much larger than our Sun live fast and die young. They burn through their nuclear fuel quickly. When they run out of fuel, they can no longer support their own weight. The core collapses in on itself, creating a region of space-time so dense that nothing, not even light, can escape. This is a black hole. Binary beginnings, stars destined for drama. Many stars are not alone. They exist in binary systems, two stars locked in a gravitational dance around a common center of mass. These systems are more common than you might think, with nearly half of all stars in our galaxy being part of a binary or multiple star system. The gravitational pull between the stars keeps them in a delicate balance, creating a cosmic ballet that can last for billions of years. Some of these binaries are wide, meaning the stars are separated by vast distances, even hundreds or thousands of times the distance between the Earth and the Sun. These wide binaries can be so far apart that they barely interact with each other, yet they remain gravitationally bound. The vast distances between them can make their interactions seem almost imperceptible, but they are still connected by the invisible threads of gravity. These wide binary systems are crucial to our story. They provide the seeds for black hole collisions. Over time, the stars in these systems can evolve and change, leading to dramatic events. The gravitational interactions between the stars can cause them to spiral closer together, setting the stage for future cosmic collisions. When both stars in a wide binary are massive enough, they will eventually evolve into black holes. This transformation is a violent process involving supernova explosions that can outshine entire galaxies. The remnants of these explosions are the black holes, incredibly dense objects with gravitational pulls so strong that not even light can escape. But their journey is far from over. These black holes, once formed, continue to orbit each other, gradually drawing closer over millions or even billions of years. Their eventual collision will release an enormous amount of energy, sending ripples through the fabric of space-time itself. This is the dramatic destiny of stars in wide binary systems, a journey from starlight to the darkness of black holes, and finally to the cataclysmic events that shape our universe. Galactic choreography, gravity's influence on stellar duos. Here's where the galaxy's gravity comes into play. A galaxy is not a uniform sea of stars. It contains giant clouds of gas and dust, along with regions of higher and lower stellar density. As a wide binary system orbits within the galaxy, it encounters these variations in gravitational pull. Over millions of years, these encounters act like gentle nudges, gradually altering the binary's orbit. The once stable dance of the binary stars becomes more erratic and unpredictable. The inevitable embrace when black holes collide. The galactic tug-of-war can have a dramatic consequence. Over time, the gravitational nudges from the galaxy can shrink the binary's orbit. The black holes draw closer and closer. Their orbital dance becomes increasingly frenetic. Finally, the inevitable occurs. The black holes collide, merging into a single, more massive black hole. This collision unleashes a tremendous amount of energy, sending ripples through the fabric of space-time itself. These ripples are the gravitational waves that astronomers can detect on Earth. A cosmic dance revealed. Insights from Max Planck. Recently, scientists at the Max Planck Institute for Astrophysics made a groundbreaking discovery. Using computer simulations, they were able to model the evolution of wide binary stars in a realistic galactic environment. Their findings confirmed the crucial role of galactic gravity in driving black hole mergers. The simulations showed that the galactic environment can significantly increase the rate at which black holes collide. This discovery has profound implications for our understanding of these cosmic events. Unlocking the universe's secrets, the importance of galactic gravity. The study of black hole collisions is a window into the most extreme environments in the universe. These cataclysmic events, where massive celestial bodies collide and merge, release an immense amount of energy, creating ripples in the fabric of space-time itself. By observing these phenomena, scientists can gather invaluable data that helps us understand the fundamental forces at play in the cosmos. These events allow us to test our understanding of gravity and the nature of space-time. Gravitational waves, first predicted by Einstein, are now being detected with increasing frequency, providing direct evidence of these cosmic collisions. Each detection is a testament to the precision of our instruments and the depth of our scientific curiosity. By understanding how galactic gravity influences black hole mergers, we gain a deeper appreciation for the intricate workings of the cosmos. The gravitational pull between galaxies and their constituent black holes shapes the very structure of the universe, guiding the formation and evolution of galaxies over billions of years. The universe is not a static backdrop, but a dynamic stage where gravity choreographs the dance of celestial objects. From the smallest particles to the largest galaxies, everything is in motion, influenced by the invisible hand of gravity. This cosmic dance is a beautiful and complex interplay that has been unfolding since the dawn of time. Black hole collisions, once shrouded in mystery, are now revealing their secrets thanks to our growing understanding of the universe's gravitational symphony. As we continue to explore and study these phenomena, we are not only unlocking the secrets of black holes, but also gaining insights into the very nature of the universe itself. The journey of discovery is ongoing, and each new finding brings us one step closer to comprehending the grand tapestry of the cosmos.